So this is GATE 2023 physics paper question number 11, which states that which one of the following entropy temperature diagrams correctly represents the Carnot cycle ABCDA shown in the PV diagram. So this is the Carnot cycle which is shown, and these are the options in the temperature entropy diagram. So we will see that how we will proceed this particular question. So this is that question where you can find out that this is the PV diagram, and A to B there is a at temperature T2, and B to C it is something, and then C to D again at temperature T1. This is what is given in the question. Now it is also being given in the question that it is a Carnot cycle. So since it is a Carnot cycle, then what will be the processes? Knowing that this is a Carnot cycle, the processes will be that A to B, since it is at constant temperature T2 given in the question, so it will be isothermal expansion at T2. Why there is an expansion here? Expansion because from A to B there is an increase in the volume. At A the volume is low, at B the volume is high. So the volume is expanding, the system's volume is expanding. That's why it is an isothermal expansion. B to C, according to the Carnot cycle, this should be the adiabatic expansion kind of thing. Otherwise, if we assume that it is a constant volume process, then it will not be a Carnot cycle. Therefore, it has to be an adiabatic expansion. We have to clearly assume that particular thing, because the way the diagram is shown in the question, it seems that it is an isochoric process. That will not complete our Carnot cycle. Carnot cycle represents some isothermal expansion, adiabatic expansion, isothermal compression, and adiabatic compression. These are the four processes which goes on. So we have to assume that B to C has to be the adiabatic expansion, C to D again at constant temperature, so it's an isothermal process. Now volume is decreasing, therefore it's an isothermal compression at temperature T1. Whereas D to A has to be the adiabatic compression in order to complete this Carnot cycle. Now what we can comment about T2 and T1, which one is greater? For that I have taken a volume V dash, that is fixed a volume V dash in both the processes A, B and C, D. So these are the points which I have drawn, which has the same volume V dash, and I will apply the ideal gas law, where for this is for P1 V dash is equal to RT1, that is for the C to D part. So this is C to D, the lower part, C to D. We have P1 V dash is equal to RT1, whereas for 1 mole of gas, let us consider for the time being, and this is for A to B, where I have P2 V dash is equal to RT2. Therefore, since V dash is constant, R is also constant. If we can see clearly from the diagram that P2 is greater than P1, so if P2 is greater than P1, then T2 must be greater than T1. If we just divide these two particular thing, so suppose this one, whatever I am writing, so P1 by P2 should be equal to T1 by T2. Therefore, if P2 is greater than P1, therefore T2 must be greater than T1. That is what I have written here. So T2 is greater than T1. Now we have to convert this PV diagram to TS diagram. Now some features of the TS diagram is that we know that an isothermal process, that is where temperature is constant, T is constant, must be parallel to the S-axis because it's an ST diagram. So this is, if I say that this is your S and this is your T, then T constant means this, whereas S constant means if it's an adiabatic process, adiabats are parallel to T axis. Why? Because in the adiabatic process we know that delta Q is equal to 0. The net heat exchanged should be 0 from the system, and delta Q according to the second law of thermodynamics can be written as TdS. So I'm just writing it as second law. So this is TdS should be equal to 0 for a reversible process, and S has to be therefore a constant quantity. Therefore S is constant, that means which line will be that? This will be something like this. This is S constant and this is T constant. So for adiabatic process it is parallel to T axis. For isothermal process it is parallel to the S axis. This needs to be clear. Now Carnot cycle in TS diagram will be therefore like this. Now which one is A, which one is B, which one is C, which one is D, we don't know, and which direction this cycle will be proceeding, that also we don't know. Therefore, in the entropy temperature diagram, this Of course, this is some T2 and this is some T1, which we have already seen, because T2 is greater than T1. We have already found out that. Therefore, this has to be T2 and this has to be T1. This blue color line is the isothermal line. Isothermal, this some kind of an isothermal process which it is representing. This is isentropic process or adiabatic process, which is represented by this particular red line. So this both are adiabatic process because it has constant entropy, S is constant, whereas these blue lines are isothermal process where temperature is constant. This thing is now clear. Now which direction this process will continue, like in this particular case in the question, there is a direction, say A to B it is moving, then B to C it is moving, C to D and D to A. Now here what will be the A, B, C, D and in which direction it will move, whether it is moving in the anti-clockwise sense or a clockwise sense, this we need to find out, because in the options, if you have seen, then there is an arrows which represents that in which direction this process will continue. For understanding that, let us consider A to B process which is given in the question. That is nothing but isothermal expansion because volume was increasing. So for A to B, which is nothing but at T2, that is an isothermal expansion at T2 temperature because it is constant. According to the first, is a combination of the first and second law of thermodynamics will tell us that TdS is equal to du plus PdV. That this we know. Now at constant temperature process, the change in internal energy is zero. For isothermal process, so for isothermal process, du should be equal to 0. Change in internal energy is 0 because it depends on temperature. Therefore, TdS should be equal to PdV, and for expansion, dV should be greater than 0 because volume must be increasing. The final volume is greater than the initial volume. Therefore, ds should also increase according to this particular expression because P and T are constant. Therefore, ds should be greater than 0. If ds is greater than 0, then since it is moving from A to B, S of B should be greater than S of A. The final entropy should be greater than the initial entropy. Therefore, S of B should be greater than S of A. Now, so at T2, where we will put A and where we will put B? So this must be A, this must be B, because S of B, you can see S of B, this one is greater than S of A, this one. Therefore, this should be the direction. So now if A and B are known now, then we can directly make the arrow. So this should be the possible direction of the process. This we can clearly see. Now, if you have to check again, check this particular isothermal line which is there at temperature T1. So let's see. C to D, which we have seen to be an isothermal compression, C to D is an isothermal compression, where we can see clearly that at T1, TdS should be again equal to PdV because du again is 0 because it's an isothermal process. Now for compression, dV should be less than 0, ds should be less than 0 therefore from this particular expression. Therefore, S at D, because the final is D, so S of D is less than S of C at temperature T1. So S of D should be less than S of C. Therefore, this should be the point D, this should be the point D, and this should be the point C. So C to D, again it is going like this. Therefore, the entire cycle should be like this, which is represented here in this particular diagram. Therefore, A, which has lower entropy than B, which we have established, S of A is less than S of B, which is clearly seen from here, and this line which is parallel to S-axis is nothing but the isothermal. So we can write this as isothermal expansion, whereas this will be some adiabatic expansion because adiabatic, so entropy is constant, is fixed, so this should be like this, adiabatic expansion. Now this is isothermal compression. Since it is a compression, we can see that there is a decrease in the volume, and decrease in the volume is actually resulting into decrease in the entropy. So that's why the entropy is decreasing from C to D. Again from D to A, it should be an adiabatic compression. So in this way, we can represent the Carnot cycle. So option A is going with what we have found out. Therefore, option A should be the correct option. So if we come to the question, so this is the Carnot cycle. So we have to assume that this is a Carnot cycle. Therefore, no isochoric. So B to C, it shows that it is a kind of a constant volume process, but it cannot be assumed because Carnot cycle is mentioned in the question. So we have to take it as an adiabatic process. And in that case, this should be the correct option. That is the option A. Other options have different arrows and different slopes and other things. Therefore, that is not the correct option. A is the correct option. Thank you.